Welcome back to ChemDoctor, and this is going to be the second video in the series on the formation of ions from elements. Now, in this particular video, you're going to need to know about basic electron configuration. So if you've not had that yet, then what I recommend that you do is you watch the two videos that I have posted on YouTube and subsequently on my website that outline the basics of electron configuration. So electron configuration number 1 and electron configuration number 2, because you're going to need to be able to ascertain when you follow me here how I'm defining what are considered to be the valence or the surface electrons. All right. So what I predominantly want to do in this presentation is just practice how we recognize when we combine either a group 1A or group 2A metal element with a nonmetal out of either 5A, 6A, or group 7A. What type of ions are going to form, and then what type of compound will result from the combination of the ions. So let's start with a similar example that we used, or that I used in presentation number 1 on ions. So we're going to look at the combination of lithium, which has an atomic number of 3. In this case, we'll use a group 7A element, chlorine, which has an atomic number of 17. Now, the first thing I'm going to do to see how these two elements are going to react, in other words, how many electrons will be transferred, is that I'm going to write the electron configuration for both elements. So for lithium, it has 3 electrons, therefore its configuration will be 1s2, 2s1, where the valence electron, remember this is out of group 1A, is here. So 2s1 is the valence for lithium. Now for chlorine, its electron configuration will be 1s2, 2s2, 2p6, 3s2, 3p5. 5 and 2 is 7. Chlorine is found in group 7A. All right? And I'll go ahead and underline its valence. All right? So there's the valence for both elements that we're going to be undergoing a reaction with where there is an exchange of electrons. So when we look at chlorine, you can see that it's got a total of 7 electrons in its outer shell. It only needs one more electron to have an electron configuration which resembles the type of configuration seen for argon, which would be 3s2, 3p6 for a total of 8 electrons. So I'm going to write that up here. We need one more electron to get 3s2, 3p6. And when we look at lithium, we see that by getting rid of this surface electron here, that it will fall back on its inner core. Right, this is the core. And its core resembles the core structure of helium, which we know is also a noble gas and has a completely full energy level 1. So when these two react, what's going to happen is we're going to transfer an electron from lithium directly to chlorine. So lithium is going to be short 1 electron. So let's take a look at this from a slightly different point of view. So lithium normally has 3 protons. We can write that this way, plus 3 protons. Once it gives up the electron to chlorine, it's going to have 2 electrons. We add these two numbers together and what we get is a net charge of plus 1. So the lithium is going to ionize to Li+. Now I used a term here, I'm going to go ahead and define it up here. So to ionize means to form an ion, right, by loss or gain of electrons. Loss or gain of electrons. All right. In this case, we lost an electron, so now in the nucleus there is a higher positive budget by comparison to negatively charged particles on the surface of the atom. Now, in the case of chlorine, its atomic number is 17. So it's going to have a total of 17 protons, which is plus 17. We've added an electron here to the neutral element. So now, instead of being 17 electrons, there are going to be 18 of them. So when we add this together, we see now there is one more electron than there are total protons in the nucleus of this atom. So the net charge on this is going to be -1. So we can write that this way, Cl minus. All right. Now, remember from the first video, we have created a situation where there are two particles that literally have opposite charges that are the same in magnitude. So there is going to be, I'll put this in words, net attraction between the two particles. So we're going to form an ionic compound called lithium chloride that'll have the formula LiCl, like that. Now let's take a look at an example that's not as straightforward. So let's say that we're going to have a reaction between magnesium and chlorine again. Let's use chlorine, so Cl17. All right, now let's take a look at the situation here. So first thing I'm going to do is run the configuration on magnesium, the neutral atom of magnesium, meaning that you've got the same number of electrons as you do protons. So Mg is going to equal 1s2, 2s2, 2p6, 3s2. That's a total of 12, right? 6 and 2 is 8, and 2 is 10, plus 2 is 12. So I'm going to go ahead and underline my valence right there. These are my valence electrons, which equals surface electrons, and this is the business end of the atom. These are the electrons that will be involved in a reaction. And again, we're going to have Cl at 17. All right, and its configuration is going to be 1s2, 2s2, 2p6. That's a total of 10 electrons. 3s2, 3p5. All right, my outer valence here. There's a total of 7. All right, I'll use the same arrow for these. So we've got a total of 7 electrons here. Now, check this out. Magnesium and chlorine are going to react in total. But unlike my first example, the relationship between the magnesium and the chlorine is not 1-to-1. All right? Because magnesium has 2 electrons it can give up. So let's deal with that animal first. So we're going to have magnesium, and it's going to give up both of its outer valence. So first, let's go ahead and count the number of protons. So we're going to have, this is magnesium 12, right? So for the atomic number, it's 12. So we're going to have plus 12 protons. We're going to lose both of these electrons. 2 electrons are going to go away. So instead of having 12 now, we're going to have 10. 12 minus 10, you see, is plus 2. So the ion that's going to result from this chemical reaction is going to be magnesium plus 2. All right? Note that when it dumps those 2 electrons or gives them away to chlorine, it's going to be falling back on an electron configuration that resembles neon. All right, resembles it. Now, I'm not saying it's turning into neon. For the beginning chemists that kind of want to do that. This didn't turn into neon when it dumped the electrons. It obtained an electron configuration that resembles neon, which is a noble gas. All right, now let's look at the Cl. You can see that only one chlorine can take one electron, and by doing that we go to 3s2, 3p6. But there are two electrons that have to be utilized, or I should say it this way, when an element of magnesium, when an atom of magnesium reacts with chlorine, magnesium is going to react with two atoms of chlorine because each atom of chlorine can only take one electron. All right, so let's see how this is going to work. So we're going to have our Cl17. See, there are 17 protons in the nucleus, and each chlorine can only take on one electron. So it's going to be, we're going to be adding a budget of -18 to that for a net charge of -1. So the Cl is going to go to Cl-. Now, when you compare Mg plus 2 to Cl-, hopefully you're with me on this. You recognize that in order for the magnesium ion to form an ionic compound with the Cl-, you're going to need two of the chlorides. So this went from being chlorine to chloride because now it has a charge on it, right? It's the anion chloride. Anion chloride, right? Now, if you can't see this, then I want you to think about another rule of thumb. All ionic compounds have charges that must sum to 0. So in other words, if we go back to this compound here and we add the charge on the lithium plus the charge on the Cl, the sum total is 0. So all ionic compounds must have their charges of the cation plus the anion equaling 0. I'm going to write that down. Must equal 0. So it's going to take two chlorides. In other words, magnesium, when it reacts with chlorine, is going to react in a 1:2 ratio. All right. So the actual compound that results is going to be MgCl2 like this, where the 2 becomes a subscript within the chemical formula indicating that there are two chlorides combined with one magnesium ion. All right. Another way of looking at this would be to write an actual chemical equation for this, which we can do. We can say Mg plus 2 plus 2 Cl- produces MgCl2. All right? And you could argue that this is a synthesis reaction on one level because we've got two reactants that are combining to make a single product. But that's probably a stretch since we're dealing with ions here. But in any case, what I'm going to do now is go ahead and close the video.